Hi guys, welcome to video number 153. This one is on bearings, and the keywords I've got for you are bearings, back bearings and clockwise. So bearings are just a measure of a turn. They are an angle and we use them to give directions. Back bearings are the same thing, it's just when your bearing goes past 180 degrees, so they're reflex angles. And clockwise is the way in which hands go round on a clock face, and we use that in this world of bearings. That understanding. So there are three key rules that you need to know to answer bearings type questions. Always measure in a clockwise direction. Always measure from a north line where the question states from, really important. And then number 3, give your bearing in 3 digits. It may also be useful to recall the allied angle factor, is what I've written there. Okay, so when you understand the allied angle factor, you understand angles in parallel lines. Okay. Now, the first question states that we need to find the bearing of P from Q. All right, that means we need to measure the bearing of P from Q. It might state that the diagram is to scale, or it might say in the words measure the bearing of P from Q. Now we need to put the protractor in, all right, and we need to pop the protractor on point Q because that's where it says from. That's the really important bit. Okay, you see there's a north line already drawn there. Okay, so I've lined up the north line with a 0. Okay, just gonna sort these bits out here. Okay, so that 0 lines up with my north line, and then this line that gets me to P, okay, that is 64 degrees. Okay, so I can see that that's a nice 64-degree angle. Now to write 64 degrees, I would use 0, 6, and 4. Okay, now that's just to avoid any confusion. All right, we wouldn't want someone to go 164 degrees when they should have gone 64 degrees, so we say 064 degrees. Okay, and that is that. All right, there's our answer to that question. Now that is that measurement there of that angle. Okay, now I just want to help you understand this allied angle factor. I've got a question on this in here. All right, but if I was to draw a north line that came from P, okay, you see we've got 2 parallel lines there. This line coming from Q and this line coming from P is parallel. They're parallel to each other. And what that makes, parallel line that joins them together, parallel line. That makes a C shape. Okay, and that's the allied angle fact. Right, and the allied angle fact is that these 2 angles inside here that make the C shape would equal 180 degrees. So that one there, if we needed to know it, and sometimes we do, that one there would be 116 degrees. Okay, because that's 64. All right, I hope that makes sense. Now I'm going to move on to B, and I'll show you an example, a slightly different example where we're measuring bearing again. And we've got P and Q here, so I'm just going to draw a line that joins P and Q together. Don't have to, but it helps for you to read off of the protractor. And I'm going to draw a north line from Q, because again, this question is asking us to go from Q. So there's my north line. Now what we're doing is we are measuring in a clockwise direction from the north line, so we're going all the way round here. All right, and this is one of those back bearings questions. Okay, and what I would do is I would measure the anti-clockwise measurement and then take it away from 360, because I know that's angles around a point equal 360. So I'd take whatever that is away from 360. I think it's the easiest way to do that question. All right, so what I need is the protractor again, but I need to rotate it round so I can do the anti-clockwise measurement. And center point of the protractor on point Q, line up the 0. So just bring that round again. There you go, and then I'll just measure so I can get to P. Right, and I think that's 127 degrees, although I'm not actually perfectly lined up with that, am I? That's a bit better. So click on that again. It just slightly moves. It's a little bit irritating, but never mind. Yeah, 128 degrees. I'll say that's 128. So all I need to do is take off 360 minus 128, and I get 232. Because it's one of those back bearings ones, gone past 180. All right, so there, I don't have to worry about it being 3 digits because it already is 232 degrees. Now you will get a couple of degrees either side of the actual correct answer in these. You don't have to be super accurate, but it really does help to get good at doing this. Oops, didn't mean to move me, meant to move the protractor. There we go. Right, let's have a look at the second question. So second question is just introducing us to a little bit of context here, which is kind of what the point of bearings is, isn't it? Very useful thing. The diagram shows a 5G mobile phone tower. Slightly controversial, although probably shouldn't be at the moment. Mark the position of person P 3 miles away on a bearing of 35 degrees. And the scale is 1 centimetre equals 1 mile. Okay, so what I need to do first in this question is decide where is the 35-degree angle, right? Now what I'm going to do is I'm going to draw a line, a north line, from that X, the mobile phone tower. This is like a plan view of a map. Okay, and if you don't understand scale, because we've introduced a bit of scale, there is a video you can watch on that I have made. And yeah, it's in the same section. All right, this one, line's going directly up from X. Okay, I need to measure a 35-degree angle from that X point. So bring that in, do the same thing as what I did in the other question. Okay, so I'm going to measure my 35 degrees, bring that around. 35 is bang on there. Okay, now I'm just going to draw a line from the X along the line there, and I'll try not to go into the words of the question, and I'm going to move the protractor out of the way. There you go. So what you can see is that this angle here is my 35-degree angle. Okay, 035 degrees. You could write that, that's 35 degrees in there if you wanted to. That doesn't look anything like 35 degrees. I am well aware of that, but I have said it out loud, so it is. Now, what I need to do is measure 3 centimeters away, because 1 centimeter is equal to 1 mile. So I'm going to put that on there, and I'm going to twist it. So I am going to measure my 3 centimeters. Now, it's almost right at the top of the line, isn't it? There's my 3 centimeters. So this is where person P is. Okay, so I'm just going to bring that in there. Just going to mark that on there with a little dot, and then I'm going to move the ruler out the way, and then get my pen back and just put point P. That's where the person is. All right. So slightly more difficult. You have to measure the 35-degree angle and then decide whether the person was introducing the scale, but actually not too challenging, I wouldn't have thought. Hopefully not anyway. Right, now third and final question, nice exam-y style one. Again, more context. A ship is on a bearing of 95 degrees from lighthouse A and 250 degrees from lighthouse B. This one, we've got to mark the position of the ship S on the diagram, and we've got 1 centimetre equals 3 miles. Well, that not relevant for this particular part of the question, but in B it says what is the distance from the ship to land, and land is over here with a little L. All right, so what we'll do is we'll measure that afterwards, and then we'll do the conversion, or just the measurement, and yeah, figure out how far the ship is away from land. So what do I need? What I need is the protractor again, and I need to just measure a bearing of 95 degrees. So from A, go A, line up the 0 all the way round, 95 is there, and then get my straight line drawing tool and draw my straight line. Okay, and I don't need to draw it much further than that, because hopefully B is going to cross that line at some point. That's what's going to happen. So I need to go and flip that around. So rotate that all the way around. Put it on point B. And I need to go 250 degrees from B. So 250 is, well, that's 180, 190, 200, 10, 20, 30, 40, 50. Okay, so I'm just going to draw that straight line. It's quite close actually. All right, I'm just going to draw that straight line through there, that point there. Okay, and you can see that that line that I first drew, only just, but it does cross the other line. Okay, I'm just going to mark that with, again, a red dot. You see this point here of intersection between the two lines. Okay, that is where the ship is. Okay, so all you got to do is measure the bearing from the lighthouse. You could draw a north line in if you wanted to. Measure the other bearing from the lighthouse, okay, and then where the two lines cross, that's where the ship is. And then the last thing that remains is for us to measure, for question B, measure the distance between land and ship. Okay, and you can see that that is 2.2 that 2.2? We'll go with 2.2. 2.2 centimeters. Okay, so let me get my pen back. All right, if that's 2.2 centimeters, okay, to get to 2.2 here, if we write this as a ratio, we can write it as a ratio, that would be multiplying by 2.2. So we need to take the 3 and multiply by 2.2. So 3 times by 2.2 would be 6.6 miles. Okay, the distance from the ship to land, it is 6.6. I'm going to put M for miles. All right. Hopefully that's really clear to you. Hopefully all of that makes sense. Yeah, please do click the link in the description. You need to get yourself a little protractor. These, I think, probably cost you about 10p from a lovely shop that sells mathematical equipment. I can't endorse any, but I'm sure there are many that do. So thanks for watching. Practice, like, subscribe, do whatever you want, but make sure you continue to watch my videos and learn and learn and learn and learn stuff that you're gonna need in your life. Maybe not this necessarily too much, but who knows, you might become a pilot or someone who captains a ship or something like that. So yeah, take care of yourselves. Thanks for watching. See you in the next one. Bye bye.